Okay, fossil fuels. We're all aware of fossil fuels, coal, oil, natural gas. They're totally ingrained within society because society runs on fossil fuels. So in this discussion, we're going to look at exactly what are fossil fuels, like how are they created, like why do they exist, where do they come from. We're going to look at how fossil fuels are extracted and used in our society, and then why fossil fuels? Why have we picked fossil fuels as opposed to other types of energy? Because we experimented with lots of other things in the past, and we looked at that in our previous discussion. So why has it been fossil fuels? Because if you go back to early cars, like in the very early 1900s, the market for cars was wide open. Whenever you have a brand new product or a brand new type of sector, which is really what automobiles were, the diversification within that field is really wide open. So in the 1900s, electric cars were actually very common. They were really popular because lots of people still had horses and buggies, even in like New York City, and electric cars ran totally quiet. We think of electric cars as very new, but the technology is pretty old. If you go on YouTube and watch Jay Leno's Garage, he owns some really old, more than 100-year-old electric cars, and he can tell you all about them. Steam-powered cars were very common back then too, and then obviously gasoline-powered cars made up pretty much the rest of the sector. But why has that won? Why has wind and solar power not taken over, or hydroelectric power? We'll get into more of the details on that next time, because next time is all about alternatives, non-fossil fuel energy. We would also throw nuclear power in there too. But today the focus is all on fossil fuels, which get a really bad rap, and kind of for good reasons, but I think a lot of it is unfair too. Now, that discussion mostly will take place in class, not in these notes. But we can get started here. So, fossil fuels are non-renewable resources. A non-renewable resource, it just means that the resource is consumed at a far greater rate than it is produced or replenished naturally in the earth. So fossil fuels take millions of years to accumulate in our planet, but there are other types of non-renewable resources. Groundwater, for example, is a non-renewable resource. There are vast reservoirs of water below our feet. If you've ever seen in a field where they have the really huge, long sprinkler systems that travel around and water the corn or soybeans, they're tapping into groundwater, well water below them. But we pump out groundwater faster than rain or other processes collect that rainwater below ground. It takes tens of thousands of years to accumulate just a couple inches of groundwater. So that's a non-renewable resource. There are others too, like metal that's found in our earth. Now, metal is not made. There's no process that creates new copper or aluminum or anything. They just simply are there. So that resource, theoretically, way into the future, more fossil fuels will be made, but not more metals. But that being said, not all non-renewables are in danger of ever running out. We're never going to mine all the copper out of our crust. Well, obviously we'd never mine all of it. What I should say is we're never going to get to the point where society, we get to a copper shortage. We've just gone too big and we can't get copper out fast enough. Copper and aluminum and iron, these things are so common in the earth, and they're so abundant that we have more of it than we need. And really, we'll get into this detail in class. If I forget, you need to remind me. Fossil fuels, the scare of running out of them, there was an oil crisis in the 70s. That really wasn't due to us running out of oil. It was actually sort of an embargo was placed on the United States by, I think maybe it was Iran. There's no reason to think that we're going to run out of fossil fuels for thousands and thousands of years. And maybe never. Maybe it'll be like the metals. There's just so much of it that we don't have to worry. Anyways, a fossil fuel is a hydrocarbon, which just means that its molecular structure is mostly hydrogen and carbon. Some fossil fuels are up to like 95% hydrogen and carbon with very little impurities. Some are only around 50%. The more pure it is with hydrogen and carbon, the better type of fuel it is. And we call them fossil fuels because they're produced from once living organisms. In your body, sorry, before I go there, your body is made, a huge portion of your body is just the elements hydrogen and carbon. And that's true for all types of life on our planet. So when living things, and it's mostly unicellular organisms for oil and natural gas it is. When they die, their bodies collect, and instead of their remains being decayed and permanently destroyed or recycled in some way or being fossilized, there are sometimes conditions where the organic matter just sits there, but the body reduces to just this oily material that sometimes we call bitumen. You can picture it as a little gross, but imagine we threw your body or a body just into a plastic barrel, and we just let it sit for centuries upon centuries upon centuries. Eventually, maybe the bones would still be there, but all the tissues and things, you wouldn't be able to sift through that, plug your nose, but you wouldn't be able to sift through that and find any hair or organs or anything like that. It would probably all kind of decay into just this ooze. And that's a little bit like what fossil fuels are. Anyways, for all the energy needs we have in this country, such as lighting our lights and making our stoves and our air conditioning work, and transportation, 80% of that is derived from fossil fuels. Renewable types of energy, like wind and solar and hydroelectric, and then non-renewable but alternative energy, which basically comes in the form of nuclear, and that's it, have started to grow in the last few decades, but still, majority we rely on fossil fuels, and that's true for all industrialized countries. Sorry. Anyways, coal. So we'll start there. What is it? It's the remains of plant matter from tropical swamps. So the United States has the biggest coal deposits on the planet. Millions and millions of years ago, the United States, because the continents have been shifting around, the United States used to sit right on the equator. So there are huge extenses of these tropical swamps. Now, why do they have to be like that? Well, if a tree falls, think about the environment of the United States today. If a tree falls in the woods or in a forest, how long is it going to last? Well, not very long, maybe only a few years. Bacteria and fungi and just the sheer weathering and erosion that goes on are just going to pulverize that wood until it's basically not preserved really at all. But in swampy areas, what can happen is the tree or the plant, it doesn't have to be a tree, any kind of plant. If you've ever walked through a swamp, which maybe you haven't, but it has this stuff called peat soil or boggy soil. There's lots of water and the soil is really deep and kind of mucky, but it's pretty low in oxygen, which means not very much bacteria or fungi can live in it because they need oxygen to survive. So it falls into that messy, sort of spongy, gooey soil, and it's preserved there. It doesn't break down from weathering or erosion or things like that, and it's not consumed by organisms. So its remains are trapped there and preserved, and then eventually the sedimentary process, the compaction and deposition of all these layers, traps it, encases it there, and its organic matter is turned into hydrocarbons. So coal occurs in many stages. The The first stage is peat, and this is just dead plant material, which kind of resembles the organic component of soil. If you have a composter maybe, where you just put leaves and things in it and you let them turn and break down, it just turns into this brown kind of mash of material. Lignite is the first type of real coal. We call it brown coal. It is actually a sedimentary rock, so that peat material has been compressed and probably subject to some heat too, along with the pressure, and it transforms it and locks it into a solid material. Peat by itself would crumble in your hand. Lignite is a little more resistant to that. Bituminous coal is rich in this stuff called bitumen. It's also a sedimentary rock, but it's much more energy dense. It's been processed a little further. The last type is anthracite. Now these two are sedimentary rocks. Anthracite is actually a metamorphic rock, so it's an organic metamorphic rock. And it's just been subject to lots of heat and pressure. That makes it much harder, but it also makes it far more energy dense as well. If you would burn all four of these material, the peat would burn all of its material. Let's say you have a kilogram of each of these. The peat would burn off first. It would burn off in only a matter of minutes. Then lignite would be next to go. I don't know exactly how long it would burn, but it would last the second least amount of time. Bituminous coal could burn for quite a while, so it would be fairly useful for cooking or whatever. But anthracite would burn the longest, so you would get the most joules or calories or whatever you want to say out of it. And here's what they look like. This is peat. It just looks like dirt. It pretty much is dirt. This is the brown coal. Lignite coal. It's also called dirty coal. Now, again, as we go through this, there's also the purity of hydrocarbon in each of them changes too. This is the least concentrated with hydrocarbons. This is the second least, the third least, and then the most concentrated with hydrocarbons is anthracite. So because of that, when you burn a very pure hydrocarbon, it produces much less pollution when you do that. So brown coal, lignite, is also called dirty coal because it has like sulfur and other elements and oxygen that react and form really terrible pollutants when it's burned. Bituminous coal and anthracite burn the longest and the cleanest of all the coals. Coal's still not a great material to burn, but it's far better than burning just pure wood or something like that. We think of wood as being like organic, therefore it's good to use. But actually, burning wood, if you had to, like if it was the 1800s and people are still cooking with not gas or electricity, but with material that they have to burn, you would think burning wood would be the natural, organic, good way to go. No, that wood has too many impurities in it. The wood smoke would be far more hazardous to your health than the evil coal would. All right, petroleum and natural gas. These form from marine organisms. The reason we know it's marine is, well, kind of twofold. One, petroleum there is so much petroleum in the world, it boggles the mind. Every minute in the world, tens upon thousands of barrels of oil are used for random processes. And tens upon thousands of oil is extracted out of the earth every single minute throughout the world. It's just unfathomable how much of this stuff there is. Now, how can there be that much of it? Well, it has to be marine organisms because the amount of life in the oceans dwarfs and embarrasses the amount of life that's on land. There's just so much more biomass in there. What also helps is when marine organisms die and they sink to the bottom of seas, ocean coasts and the bottoms of oceans is super rich in sediment, so it's very easily buried underneath all that stuff and can be preserved. Now, it's unicellular organisms that become petroleum. If every single dinosaur that ever existed died and did convert into oil rather than just being decayed or turned into fossils, we would burn through every single dinosaur in a couple of minutes on our planet. I mean, really, there were billions of dinosaurs that existed, but we use so much petroleum that their remains would be gone. So it's things like algae and plankton and radiolaria and diatoms that make up what our petroleum is, and natural gas. So natural gas comes from petroleum. It evaporates from the fumes that come off of petroleum. And also sometimes coal deposits release natural gas too. But I don't know what it is as a percentage, but most of it comes from petroleum. So here's like some crude oil just sitting on the surface. And you can see it's bubbling up. And those bubbles are methane gas. That's, when we say natural gas, we mean methane. All right, there are also tar sands and oil shales. So, tar sands are, it's literally sand with bitumen oil mixed in throughout it. Oil shale, though, is more interesting. It's a sedimentary rock, but it's not like coal or anything like that. It's just simply, shale is compressed mud, if you remember from chapter 3. So, although the rock is solid, on the microscopic level, it's very porous and spongy. So there's room for oil and bitumen to get into the grains there. So that's what happens. It's literally a sedimentary rock with oil mixed in it. It smells like asphalt. If you've ever, when they're making parking lots or fixing the street or potholes, that has a really distinct smell to it, the asphalt they lay down. Oil shale smells pretty much exactly like that. So here's a tar sand operation. Canada has these massive tar sand deposits. It's a huge part of what drives Canada's economy and why they are I think they're a top 10 producer in oil in the world. But it's really disgusting and really dirty. And it's a really hard process too to extract the oil from it. It's not very cost saving. It's only within the last decade or so, we've figured out a cost-effective way to extract oil. Because yes, you can sell oil for money, but what's amazing about oil in particular is it comes out of the ground as this kind of material. Now think of how much work and how much time and how much energy is used in turning that into, for example, gasoline, which is a highly purified version of this. It's got to be dug out of the ground in Saudi Arabia or somewhere like that, put on a shipping vessel, which burns thousands of gallons of gas, shipped all the way around the world, put into factories for long periods of time to be reduced and chemically refined, and then put into trucks and shipped all around the country, which burns even more gas. We're burning petroleum in order to make petroleum. And despite all of that, despite all the effort, you can buy gasoline for $2.80 a gallon right now or something like that. It's cheaper than milk is. And milk, the cows are everywhere. You don't have to ship it nearly as far. It's crazy. But the big part about that is just how common they are. And the fact that people always buy fossil fuels in huge quantities. So they can afford to sell it for cheap. But anyways, this is what tar sand looks like. And oil shale, I mean, it's literally flammable. These rocks can potentially just be burned the way they are. Now, that's not what we do with oil shale. You know, you picture like an old steam locomotive. You got the one guy shoveling coal from the coal cart into the engine bay. No, we don't burn oil shale and get energy from it. We use a method to get the oil and natural gas out of the rock. We want to separate them. It's more useful that way. So, how are they formed? Now on to how are they extracted. So coal is just simply mined either on the surface or deep below the surface. Subsurface mining still is, but it's better now than it was. But it's still far more dangerous because there are toxic but undetectable fumes. There's the risk of cave-ins because you're mining out the earth around you, so you're weakening it. It could fall on you. And lack of ventilation. It's very hot and dirty. When you mine for coal, it creates all this particulate matter because as you chip away or mine away rock, well, some of it just turns into dust and powder, so you get like black lung disease and can get in your eyes and everything as well. Really not a good line of work. Not at all. And as far as the toxic fumes, maybe you've heard of canary in a coal mine as a metaphor. Today it's used for people who are like whistleblowers perhaps, or as an early sign of that something's going on. People literally today we have sophisticated electronic measuring instruments that can detect even minute levels of toxins. But before that, before we had electricity and things, they would literally take a bird cage with a canary in it and they would keep it in the coal mine. And so if there's toxins in the air, a small organism is going to succumb to those toxins much sooner than a large organism like a person would. So they would keep this bird, and it would be somebody's job to watch the bird, and if the bird just dropped over dead all of a sudden, then they would know, oh, time to get out of here. It's pretty ingenious, cruel to birds, but pretty ingenious. Surface mining it's less expensive because there's less preparatory work to go on, and it's much less risky, but it does expose the environment more because all of the mining is on the surface. So here's a below ground mine. It still does go on. I don't know as a percentage how much is surface mine versus below the ground, but here we go. Here's a guy working there. Now his shirt and pants, his shirt by the looks of it was white or light gray, and his pants were probably khaki, but he's just absolutely coated head to toe in black dust. And I don't exactly know what this machine is doing, but you can see the drill marks and whatever, so it's mining out a thin section here. So you can just imagine that these conditions are pretty awful. And here's the surface mine. So we have the sedimentary rock above, and that was encasing this coal below it. It might be metamorphic coal or it might be sedimentary coal. But I mean, there you go. It's a really stark contrast between normal rock layers that you can see anywhere and just a black, no layers, just uniform and black. That's coal. And this is sort of like a fossilized, petrified, swampy forest, but not exactly. In the United States, Wyoming by far produces more coal than any country, and they're pretty much all surface mines. The top 5 largest producing coal mines in the country are all in Wyoming. So it produces as much, just slightly less than West Virginia, Kentucky, Pennsylvania, Montana, Texas, Indiana, and Illinois combined. So a big part of what was going on when Trump was getting elected, they don't really talk about this much anymore, but it was a huge talking point in 2016 when he was running, and it was a huge talking point for the first half of 2017 after he got elected. He would bring coal miners from West Virginia and Kentucky into the White House or at his rallies, and he would talk about them all the time. But none from Wyoming for whatever reason. Who knows? As far as in the world, China produces as much coal, or pretty close to the same amount of coal as every other country in the world combined. It's just unbelievable. Now, China is a huge country. It's the 3rd largest country by square miles on the planet. But they also just have huge deposits of coal. So they're number 1 with, I think is around 3.5 billion. What is it? Yeah, I think it's around 3.5 billion tons of coal every year they dig up. It's unbelievable. India is actually number 2, just a little bit ahead of the United States. And then we have Australia, Indonesia, Russia, South Africa, Germany, Poland, and Kazakhstan is number 10. These countries here, the top 10 countries, represent 90% of all the coal that's dug up on the earth. As far as coal consumers, so this is countries that dig up coal. If you go to consumers, China actually, they have to import coal. They don't dig up, even though they dig up all that coal, they still need to import coal from other countries. China, they have a population of 1.5 billion people, but China is, America went through its industrial revolution in the 1800s. China is more or less going through has been going through their industrial revolution only since like the 50s, 60s, and 70s, the 1950s, 60s, and 70s. So they're catching up, and because they have such a huge population compared to us, of course they're going to be consuming more. I mean, it makes perfect sense. So there's their representation. India is also number 2, and the United States we're number 3. Quite a lot of that has to do with the fact that we have the 3rd biggest population in the world. So here, as far as consumers, the world's largest population, the world's 2nd largest population, the world's 3rd largest population. I think Brazil is the 4th most populated country, but you can fact check me on that. But it's not Russia. So then Germany's population is around 65 million people, so there they are. Japan, which is a very industrialized, techie country. South Africa, South Korea, Turkey, Poland. These countries, the top 10, represent 80% of all coal consumed on Earth. Now, if we look at the United States, we produce 10% of the coal, and we only consume around 10%. The United States actually exports coal. We burn we burn a couple 100 million tons less coal than we extract. So we're able to ship out to the world hundreds of millions of tons of coal every year, which is good for our economy, really. Okay, oil and natural gas are tapped through drilling. So once you drill a hole, the natural pressure that locks in the petroleum and natural gas, that alone will lift up most of the material without any work having to be done. I can't believe how long ago this was, but the BP oil spill, I think that happened in 2012. So you probably weren't paying attention to that. It was a really terrible thing. Inside the Gulf of Mexico, British Petroleum, which has now changed their name to Beyond Petroleum, but it's still BP. They were drilling for oil in the Gulf of Mexico, and they start off with a hole that they drill, and they build like a gigantic metal ring with threads in it to contain and be able to capture the material that comes out. Well, something happened where it broke, and the oil was just pouring out of the hole, and there's nothing they could do about it. Natural pressure, there's no machine on Earth that could push down against the natural locked pressure inside the Earth's crust to stop that. So they had no choice but to just let billions of dollars worth of oil leak out of the hole, and it killed lots of fish and pelicans and things. Anyways, there's that. And after that point, the pump jacks, the things that tilt back and forth, those are a hydraulic way of pulling the rest of the oil out of the ground after natural pressure can't do it anymore. Globally, 30% of crude oil is gathered offshore, which is a pretty good share. The United States, only 18%, which is still a lot. That's a little more, that's about a fifth. Alaska, Texas, and Louisiana are the states that have the most offshore drilling. And 27% of global gas production comes from offshore. The rest of it, obviously, on land. I don't know, I couldn't find the figure for the United States, but I'm pretty sure it's very, very low. So this looks like a forest, but it's not. This is a picture from the very early 1900s, maybe late 1800s, probably early 1900s. But these are actually city streets, and some of these are houses. Every one of these things is the old-fashioned oil rig platform, right? So exactly know how these work, but this structure would support the pipe and the weight that would drill into the earth. So they're not trees, they look like trees. It's an oil field. And I mean, there's just hundreds of the things in this picture. It goes way, way, way out. Now, you're gonna be really, really surprised when I tell you what city this is. It's in the United States, but it's not somewhere in Texas. It's not somewhere in Oklahoma. This is Los Angeles back then. Los Angeles still has hundreds and hundreds, maybe even thousands of pump jacks still operating. If you know about the famous tar pit, it's called the La Brea tar pit in California. We have found thousands and thousands of preserved Pleistocene mammals, saber-toothed cats, woolly mammoths, well, not woolly mammoths, but mastodons have been found in there, Columbian mammoths, things like that. We found camels and bears and horses all those animals are now extinct. But that's in the tar pit. Tar is oil, so we know it's there in California, but yeah, actually, California is one of the leading producers of oil in the country. So here's a pump jack. Here's kind of the anatomy of it. So the pipe that goes within there has, I don't exactly know what all this stuff is, but within the tube, there's an inner piping system for extracting out that oil. So, and then they just simply divert it. Yeah. I don't exactly know how these things work, but there's a schematic anyways. And here's one of the offshore oil rigs. Probably seen pictures of those before too. In the United States, Texas produces about 50% of all the oil. A lot of that has to do with the fact that Texas is gigantic, but it also is probably the most rich with oil. It has the most oil reserves, we say. North Dakota, number 2, but that has only been the case for about 15 or 20 years. I don't know if North Dakota was even on the map before that. But there you go. California, there, number 3, so lots of oil. Alaska, a lot of that comes from offshore. Oklahoma, New Mexico, Colorado, and Wyoming. 90% of all on-land drilling comes from just these 8 states. As far as in the world, the United States is the leader in oil. We're only separated from Saudi Arabia by around 10 million barrels a year. So I think well, actually I can tell you. Let's actually look at it. Open the chart data. So we produce 580 million barrels a year. They produce 560 million barrels a year. So not all that much different. And then Russia, no surprise there. Canada, because of the tar sands and deposits they have. Iran and Iraq, so famously oil controversies with the Gulf War, with the Iraq War and the Afghanistan War that the George Bush administration led us into. Lots of controversy around there. China, not so much oil. They're more dependent on the coal. UAE is the United Arab Emirates. So it's a really small country, sort of embedded on the coast of Saudi Arabia. That's where the tallest building in the world, the Burj Khalifa, you've probably seen pictures of that. That's in Dubai, which is part of the United Arab Emirates. The other famous city in that country is Abu Dhabi. Kuwait, another dictatorship, Middle East country that gets all its money from oil. And Brazil, which is kind of sort of a bankrupt, semi-backwards, semi-kind of communist country. Oil seems to if the country has a lot of oil, it seems to lead to quite a lot of corruption. Canada is our last hope. Oops, sorry. This is oil consumers. The United States really, really dominates oil consumption, and a lot of that is transportation. China, yeah, they're developing, but still, transportation in China is not quite as big a deal as it is in the United States, but they will probably one day get there. But as of now, we are far ahead of everybody. Japan is number 3, then India, Russia, Saudi Arabia, Brazil, Germany, Canada, South Korea. There we go. So this diagram shows what a useful trapped oil reservoir looks like. So although this is kind of what it looks like, it's not a giant cavern or like a cave or an open pit with oil sitting in it. No, it's solid rock. It's totally solid rock, but it has oil embedded within its grains. Now, this is what we call an anticline. Plate tectonics just has a funny way of, it can push layers like that when it squeezes them. And that's what causes the pressure that makes the oil and natural gas release from the surface. I'm not going to play it today, but I do have a video clip from a movie. This is about an oil baron who lived in America. It's fictional. It's not based on a real person exactly. But he had oil drilling operations all around the country, and they actually show in this video what it's like to extract oil out of the ground. It's a pretty messy process. So we can watch that in class, just remind me. Tar sands have to be heavily processed. Basically what you do is, to separate the oil from the sand, you gotta boil the oily substance in water and chemicals for long periods of time, and then you can leach the bitumen from it. Natural gas and oil are taken out of oil shale by fracking, which stands for hydraulic fracturing. So that's what they're doing in North Dakota and in Oklahoma. It's been really controversial, but fracking also, I think it gets a bad rap. I used to be on the team of, yeah, down with fracking, let's hate fracking. But after I looked at the facts, instead of just listening to people talk about how bad it is, you start to realize there's a reason we're doing it. It is fairly safe. Terrible things have happened, but those are isolated events. The vast majority of cases, nothing catastrophic happens. And the other thing that's great about it is it helps make gasoline and products in our country cheaper, because if we don't have to buy oil from Saudi Arabia or Iran or Iraq, these countries that we shouldn't be supporting, then everything is cheaper. If we have our own oil, we cut out the middleman. So it's a great thing, really, and it's done wonders for North Dakota's economy. Anyways, what they do is they drill a hole, or they drill kind of like a well into the oil shale below ground, and then they pump, this is the hydraulic part of it, hydraulic is moving fluids, water, chemicals that can dissolve the rock and grit like sand and things like that. They pump it into the hole that they drill, and the huge pressure causes the rock to crack and break and fracture. The grit gets in between those cracks and keeps the cracks from closing in on themselves, and that naturally releases oil and natural gas. Now, I thought that fracking was used mostly to get oil, but it turns out that I believe we're getting mostly natural gas out of these fracking mines, and maybe it's different depending on the area. Here's a really kind of crummy but decent way of depicting what's going on. Breaks the rock around it. Now the problems with these that have been illustrated are there is groundwater below us, and here in town and in these rural places, the water you drink comes out of the ground. The water you wash your clothes with, take a shower with, and drink, comes from below ground, and there are lots of obviously very toxic chemicals that go into these mines, and there's always a danger that it could leak into the water system. Now, so far, some studies have shown that it has happened in small doses, but considering how many fracking operations are out there and how little evidence there is that it is occurring, it's something apparently that we can live with. I don't feel like looking at this. You can pause and read through these figures if you want, but I'm going to gloss over this for now. One of the funny things about fracking is it can cause earthquakes because you're destabilizing the ground below you. An earthquake that could destroy a building? No, but it can happen. One of the other things is you can see videos on YouTube of people, the fracking, because it releases natural gas, that natural gas can leak into the water too. And some people, they hold a match up to their kitchen sink as it's running, and flames shoot out of it. It's kind of funny. Now that kind of thing does also happen naturally, and there was this kind of scare about it with, excuse me, with fracking, but it doesn't appear that fracking actually increases the rate of that really rare but natural phenomenon happening in the first place. But in Oklahoma, this is really crazy. They really started getting into fracking fairly recently. So before they were doing that, Oklahoma was averaging around not even 2, a little more than 1.5 earthquakes a year that were a magnitude 3 or greater. And in 2014, they had, almost 600 of them. So, but what's really too bad about this kind of thing is, yeah, this is from the US Geologic Survey, but actually the fossil fuel companies themselves have lobbied Congress, and they made this really terrible deal where what they've this deal that they've cut, and this deal is terrible because it's a major conflict of interest. But what's happened is oil companies and coal companies or whatever, they have been able to make a deal where they're the ones that are responsible for carrying out scientific research about the environmental effects of their practice. So it doesn't take a genius or a rocket surgeon to understand that that's a huge conflict of interest. Because what are they going to say? They're going to say, nope, nothing happened, or nope, there's no negative consequences. When, of course, there are. So the funny thing with these earthquakes was when this data came out, they didn't say that earthquakes weren't happening. They're like, yeah, the number of earthquakes increased 500-fold. But they said that there was no evidence that it has anything to do with fracking. Well, come on. It is from the fracking. Now you can go ahead and make the case pretty easily that it's not necessarily dangerous by any means, but don't just say that it has nothing to do with it. Anyways, I'm ranting. Okay, now how are they made? How are they extracted? How are they used? Historically, coal was used to cook food, heat homes, and manufacture metal tools. That was it. Now, we don't use coal for any of that today, pretty much. I mean, a tiny bit, at least in industrialized countries, we don't. In developing countries, maybe they do heat their homes a little bit with coal, but that has completely gone away from the modern world. With the Industrial Revolution, what coal was first used for was to power steam engines, which caused manufacturing and transportation to increase exponentially. The UK, England is where the Industrial Revolution started. And if you know your history, if you go and watch like a crash course history video, the textile industry in Great Britain, the manufacture of like cloth and stuff like that, it just exploded. Machines were able to sew and produce material at the rate in a day that hundreds upon hundreds of workers could. And machines don't get tired. You don't have to pay them. They don't have to take breaks. You have to maintain and repair them, obviously. But it's just unbelievable how much better off that makes everybody. And then transportation, so the railroad system in the United States. I mean, the idea of being able to travel 200 miles in one day, I mean, that was mind-blowing. That would be like somebody, there's no real good comparison for it, but it'd be like somebody in the year 1920 when there were cars and trains and things like that in the United States, but there weren't any commercial airline companies, right? Have that person wake up, let's just say not even today, in the 70s. So they're only going forward 50 years, and you can tell them, yeah, for a couple $100 or whatever, probably wouldn't cost that much in the 70s, but if we adjust it for today's money, yeah, for a couple $100, you can fly from New York to Paris and you'll be there in 10 hours. I mean, to that person, that's just It's not even thinkable, feasible. Anyways, so today 37% of all electricity, so this is what coal is used for today, making electricity. 37% of global electricity, and pretty much the same percent in the United States, is coal generated. But almost 93% of coal is used directly in making electricity. So these aren't contradicting each other. What it's saying is virtually, so 93% of coal is used for generating electricity, but because we generate electricity in other ways through hydroelectric and dams and solar and things like that, coal doesn't totally dominate all electricity that's made. Making electricity does dominate the use of coal. The other uses for it are in the manufacturing of steel and concrete. To make steel, you have to melt down your iron and combine it with carbon. So that requires huge amounts of heat. So coal can be burned directly to do that. And making concrete, same sort of idea. The US consumes around 97 million tons of steel every single year, compared to almost 700 million tons of coal. And concrete is the second most consumed product in the world. The only thing that beats it is water. So we build our infrastructure on concrete foundations and steel skyscrapers. I got a funny story. This doesn't really have to do with anything, but it's related to this. Henry Ford, the guy that started Ford Motor Company, he invented the concept of the assembly line. So he's a big reason that wide-scale production really exploded in the early 1900s. But the guy did so many great things, but he was also very weird. He was a raving anti-Semite. He actually published, he paid for himself and ran. He really wasn't involved in writing articles or anything for it, but he paid for a magazine that came out regularly. That the magazine existed for no purpose other than to slam Jewish people. And that was it. It was a propaganda thing. But he firmly believed that the Earth's crust would be destabilized and cave in from the making of skyscrapers. He thought that they were too big, and there'd be. If you look at a city like New York or Chicago, it's just unbelievable the concentration, how tightly packed and how numerous these many hundreds of feet tall buildings there are. But what's funny is Henry Ford had explained to him thoroughly by professional engineers that, no, Henry, look, in order to build a skyscraper, you have to drill down and extract a huge volume of solid bedrock below to lay the foundation. And then you pour in concrete and cement into there. Well, it turns out that the ground underneath a skyscraper actually weighs less after doing that, because you take out solid rock and you pour in concrete, which is actually pretty porous, and the steel doesn't weigh anything like what solid rock weighs because the building is mostly hollow. So no, actually, Henry, the opposite of what you're afraid of is the case, and he wouldn't have any of it. He didn't believe them, basically. Getting back to Trump and the coal jobs and all that kind of stuff, this is important to understand, because it's important to understand what the facts are and how not to be duped by people, politicians, and I'm only picking on Trump because he is the president right now. There's nobody else to pick on. People that are Democrats lie about crap all the time too. But so the coal job was the big thing. Trump, a huge part about what he ran on was, it was Make America Great Again, which the immigration thing was a big part, but bringing jobs back to the country was the thing. Trump said he's going to bring back the coal jobs. That the only reason the coal jobs went away was because the Democrats did a bunch of stuff to ruin the coal jobs. That's completely, totally not true. What happened is, so here's, this graph shows consumption of US coal. I don't believe it's specifically for electricity, but that's what most of it's used for. And ever since, well, I mean, just look, the amount of coal that we've used has gone way, way, way down. It's been replaced by natural gas. So the fossil fuel industry is what killed the fossil fuel industry jobs. Natural gas it's cheaper to use, it's easier to transport around, and it's cleaner. If you remember way back in the first, I think it was one of the very early discussions we did. I showed you the city of Shanghai and how on a really bad day with lots of smog, it just looks so dirty and gross versus a clean day. Well, New York City used to be like Shanghai. You would have clean days, but then there were some days where the air was so incredibly dirty. It's a very population-dense city, but that was because they got most of their electricity from coal. New York has since switched to natural gas, and it burns cleaner, and they never have those kinds of days anymore. And here's like a coal. This is probably a power plant, although it could be a manufacturing site. I don't really know, but inside there they just burn coal and generate electricity. All right, petroleum. What do we use it for? Petroleum is it's unbelievable what we have figured out to be able to do with petroleum. It's by far the most versatile raw material on the planet. It can be transformed into so many different things. It's really unbelievable. Every single activity that you will do today involves petroleum, and nearly every single product that you use contains petroleum. There's almost nothing that you handle day to day, minute to minute, that does not have a petroleum product inside of it. The vast majority of petroleum use is for transportation, 93% of it. I'm sorry, I said that wrong. 68% of what we use oil for is transportation. 93% of transportation uses oil. So like electric cars don't represent a very big portion of the market. Electric like cabooses and trains like that, yeah, they exist, but they don't represent a very big share of what's out there. So to give you an idea of the versatility of petroleum, petroleum is the source of the lion's share of these products. Fuel, that would include diesel, gasoline, jet fuel, but also cooking fuels like propane, butane, and a few others. Paints and dyes are based on petroleum, rubber, plastic. So I could just take fuel, rubber, and plastic, and right there is the majority of stuff around you. Fuel for us to transport and make a lot of our food, but rubber and plastic. Can you imagine a world without rubber or plastic? Imagine your car without any rubber or plastic or paint in it. All you're left with is the body of the car and virtually nothing else. Styrofoam, insulation, acrylic, polyester, nylon, spandex, asphalt, candy, not like chocolate, but like any kind of gummy candy, like jelly beans, gummy bears, gummy worms. That's actually what makes it gelatinous is a petroleum product. So you're eating fossil fuels. Shingles, lubricants, makeup, waxes, ink, all of these things. I mean, just think about, like, look around a room or pick an object. How much of it is based on petroleum? It's just crazy to think about. Let's take a car. Car's a great example. Now you think, okay, yeah, there's excuse me, there's gasoline in the gas tank, a couple gallons of it. Well, that's not it. All of the paint on the car is based on petroleum paints. All of the plastic on the car, which is going to be the bumper, most of the materials on the inside, the dials and switches and coverings that hide the wiring and all that kind of stuff, the headlights, the taillights, all of that is petroleum-based because it's plastic. Rubber, the tires are made of that. All the insulation for all the wiring, all the hoses that connect the air conditioning and the brake fluid and this and that, all of those things rubber. The foam padding in the seat is foam and insulation. It's entirely based on petroleum. The material that covers the rest of the inside of the car, the fake leather maybe that's on the dashboard, that's made of petroleum. If you have real leather seats, then no, that's not. But if you have fabric seats, they're made of polyester or something like that. That's going to be petroleum. The only thing in a car that is not petroleum are the nuts and bolts that hold it together, the body frame of the car, and then the glass. I mean, that's it. That's the only thing right there, pretty much. So here are the uses of oil by sector. So about 70% of all oil that is used by the most oil-intensive country in the world is for moving around. Next is industrial, so manufacture of products and things like that. We can make electricity with oil, but it's really not used very much. Coal and natural gas and renewables like hydroelectric and wind are much better for that. Residential, so you can use oil and burn it in your homes, but it's a very small percentage. And then commercial, I'm not sure exactly what that would be, if that's like the manufacturing of lipstick and things like that, but there you go. If we look at oil, where is oil? It's in the blue here. Now coal, this goes way back to the 1800s. Coal represented virtually the entire source of all of our carbon. So this is actually, this black line is carbon emissions. It's not exactly our use of fossil fuels, but it's pretty much the same thing. And we can see from, when the Industrial Revolution really kicks off in the US in the mid-1800s, all the way to, well, right about 1925, coal is pretty much everything. It's how people heated their homes. It's how people cooked their food. Nobody had cars. So transportation was all thanks to the steam engine, which is powered by coal, the heat from coal. And then oil really, really takes off. Here's the oil crisis of the 70s, the embargo that happened. But, petroleum has really, really taken off. Natural gas, it was hard to find any use for it right away, but now it's really started to take off, partly because we can extract it better, but also because we found better uses for it. So here's total energy consumption, and you can see oil, and this is world. Oil is the dominant one. It's not coal. Oil is far more common, and we have far more uses for it. Again, if we look at natural gas, this only goes back to 1970. Natural gas has been creeping up. It's probably going to surpass coal in the next couple of decades. Hydropower has been increasing a little bit. Nuclear power, so this one's kind of interesting. It's non-existent, and then it goes up, and now it's pretty much flatlined. The reason it has flatlined is because in 1980, it was either 86 or 88, I don't remember, but that is when the nuclear accident at Chernobyl happened, and it pretty much scared everybody into not pursuing advances in nuclear power, which is really a shame, because nuclear power is most likely the future, way more so than wind and solar are. Oil consumption, thousands of barrels per day. So the United States, 20,000 barrels of oil every single day. That's just tremendous, and most of it for transportation. Canada and Mexico, you can see them there. Central and South America, we can see them there. Now the whole continent of South America and Central America, look at how small they are compared to us. Why? Well, America has been settled and colonized and industrialized thoroughly. These parts of the world, not so yet. It's a little more difficult with the environment and the natural resources they have. Europe, so we're comparing the United States to all of Europe. Here's why this is amazing. The United States only has half the population of Europe, yet Europe consumes less oil than we do every day. Twice the population, but less. So essentially, per capita, they are less than half of what we are in the United States. Is that a good thing or a bad thing? I don't know. I think in this country we are way, way, way too wasteful, but oh well. Asia and Oceania, so we, Asia and Oceania that would include Australia. So just with China and India alone, that's more than 4.5 billion people. I mean, Asia and Oceania is approximately half of the world's population. So half the world's population is about 3.5 billion. That's 10 times more people than the United States population. We're at 20,000. They are just over 20,000. So look at what first world industrialized living standards do. The rate of consumption we have is just phenomenal. Now again, this is 10 times the population, not at our level yet. One day, those groups of people are going to be at our level. And this is where we have to start being careful about, do we have the policies and the infrastructure and the ways to deal with this stuff appropriately? Because we're going to see this yellow portion is going to go down to, it's going to take up most of this graph, not too far in the future probably. And are we adequately dealing with the pollutions and everything that's going to come with? All right, by a percentage, now this is by country. The other one, those were mostly continents. Actually, we looked at this already, so I just kind of wanted to show this again. The United States is way, way up there. All right, how do we use natural gas? The most common use for natural gas is making electricity. You can burn it, and there's some other steps in there, but we make electricity with it. Because it's cheaper and cleaner and easier to transport, it's been taking over for electricity generation in industrialized countries. In developing countries like a lot of Africa, actually we should go back and look at this. This is the entire continent of Africa. Look at how absolutely narrow their oil consumption is. They're not developed yet, they're developing. So in a country like Africa, they will use coal to make electricity. Lots of places in Africa, actually, many of the countries rely almost entirely on hydroelectric power. But coal it's just simply easier to use coal to make electricity. Once you have the infrastructure built for natural gas, then you can go ahead and use it, and it's cheaper and the payoff is better. But when you're starting at square one or square zero, it's much, much easier to use coal. You can also burn natural gas in order to manufacture things like coal was done, but we can also use natural gas to make things like fertilizer, certain fuels, plastic, ammonia. Some aerosols, I think, use maybe some natural gas. But making electricity is most of it. And then the industrial uses actually are a pretty good chunk as well. Residential, so your home is most likely heated with natural gas. You can look at it on your bill. I look at mine every month and compare it. Older homes used like electric running boards that would heat up the room. But natural gas is cheaper and it's more efficient to heat an entire house. And then commercial use. There is such a thing as natural gas cars. Now, they don't burn natural gas, but you convert the natural gas into a liquid fuel. I have no idea how that works, but I know that it is something that's out there. So how is electricity in the United States made? Again, here is coal, seeing its production go down as natural gas has been taking over. This graph is a little hard to look at. You have to look at the width of the slice here. So nuclear, it looks like nuclear's been growing, but actually if you take this width and I apply it down here, even over here, the share of nuclear is the same as it was over here, and that's kind of because we haven't been shutting down nuclear plants, but we just haven't been building any new ones. And you can see renewables, have been growing a fair bit fairly recently. If we look at nuclear, you know, it didn't even exist at all in 1960. Right? So why fossil fuels? This is the last part, very short section. Why? Why have we picked them over nuclear and over wind and solar and all those things? We'll expand on this more in the next section, but these are the big reasons. Fossil fuels are the cheapest, the most plentiful, the most energy dense, the easiest to import and export, and they're the most reliable. The wind doesn't always blow. The sun doesn't always shine. A hydroelectric dam is pretty constant and pretty regular. That's pretty good. But the others is just not really quite there. Now, nuclear is kind of an exception, although nuclear can be pretty expensive to set up. Renewable energy, it's just way too hard to harness it and to capture it. In the last section, we looked at, you know, what we were able to do with wind-driven boats, for example. Well, not very much, in truth. It's also very difficult to control. You cannot control the wind. You cannot store wind or light. We still can't really store any of those things, although Tesla is, well, not exactly Tesla, but Elon Musk's company is working on building a battery that you can attach to the side of your house that will store. So let's say, you know, you go to work for 8 hours. Well, that's when the sun is out. So if you have solar panels on your roof, they're not doing you any good. But they're building a battery pack that gets charged by those solar panels when you're at work. So you come home, and even though maybe the sun's almost setting, you can still run the lights off of no fossil fuels whatsoever. And it's very hard to regulate them as well. And it's really the only reason that alternative energy has even had the chance to do anything is because the manufacturing process that fossil fuels allow, the huge manufacture of concrete and steel to build infrastructure, that's the only way we've been able to do that. If you look at a wind turbine, think of all the metal that's responsible for that. How was that metal made? Well, it was made with fossil fuels. So just look at the energy density, because this is important. Now, nuclear ought to be the future. Don't know what'll happen, but look at this is megajoules per liter. Look at the energy density of these radioactive isotopes. Uranium, over 1.5 million joules. Thorium, almost 1 billion joules. Plutonium, 43 million billion. Pretty crazy. Compare that to coal. Coal is the next best material on our planet for making energy, but it's 38 compared to 43. So it's worse than 1 million times less energy dense. But this is the reason that we have used these. Coal is very energy efficient. Diesel is more so energy efficient than gasoline. That's why many car companies release diesel versions of their cars, because it helps keep their regulations down, because governments tax them for their pollution and things like that. Animal fat is actually pretty darn high in energy density. A long time ago, that's how city streets were lit, was with whale blubber. Propane, pretty high up there, methane. So now we'll compare kind of like the alternatives. Wood, energy density of only 13. So if you want to try to heat a home or do a manufacturing process with wood, you have to burn way more wood than coal in order to be able to do that. Here's the lignite, the brown dirty coal. Yeah, it's not a very good fuel. At worst, it can be only 10. At best, it's only 20. Different types of batteries. Notice how low their energy density is too. Now, battery technology is one of those things that has not evolved hardly at all in the last couple decades, but it has been slowly creeping up in efficiency. I've watched a very good video on PBS Nova about new battery technology. Theoretically, batteries just have problems in the way they're structured and made. They can blow up and things like that. But we have now figured out a new way to make batteries that makes them, I mean, it would make them more than 10 times more efficient, way more. I can't exactly remember what. But right now it's in its early stages. We still don't know how to mass produce them yet. But you know, we didn't used to know how to mass produce cars or anything like that either. But we figured it out eventually. Right.